Intersection of a line and a circle. When a line and a circle are said to intersect, the possible situations we can have are what you see on the screen. The line can intersect the circle at one point, as in the first figure here. Then another possibility is that the line can intersect the circle at two different points, as we see here. And then it is also possible that the line will not even intersect the circle at all. So when this happens, then we say a line is intersecting a circle. Example, find the point of intersection of the circle x squared plus y squared plus 18x plus 20y plus 81 is equal to 0, and the line y is equal to x plus 1. Okay, so solution. We can determine this by solving the two equations simultaneously. So we have a linear equation and a circular equation. Always when you have two simultaneous equations where one is linear and the other is polynomial, it is advisable that you substitute the linear one into the polynomial equation. So here we will substitute x plus 1 for y in the equation of the circle given. And so we're going to have s squared plus x plus 1 squared plus 18x plus 20 times x plus 1 is plus 81 is equal to 0. So s squared here plus s squared plus 2x plus 1 plus 18x plus 20x plus 20 plus 81 is equal to 0. So s squared plus s squared, that is 2s squared. 2s plus 18x will be 20 plus another 20, that will be plus 40x. Then we also add a constant. We have 81 plus 20, that will be 101 plus 1, that will be 102. So 102 is equal to 0. So I can divide through by 2 to get the equation as this. Now with this, I solve as a quadratic equation. So looking at 20x and 50, I can rewrite it as s squared plus 3x plus 17x plus 51 is equal to 0. So I'll have x and then x plus 3 plus 17 out, x plus 3 equals 0. So I have s plus 17 and then x plus 3 equals 0. So my x is equal to negative 17 and s is also equal to negative 3. Now I need to find the corresponding y value. So when x is negative 17, y will be equal to negative 17 plus 1, which will be negative 16. And then when x, so this one will give me the point -17 and -16. And then when x is 3, y will also be -3 plus 1, which will be -2, which will also give me the point -3, -2. So these are the points where the line and the circle intersect.
Find the point of intersection of the line x minus 1 equals 0 and the circle x squared plus y squared plus 18x plus 20y plus 81 is equal to 0. Solution. So we are going to take the linear one, x minus 1 equals 0. Now we make s the subject as s is equal to 1. And we are going to substitute s equal to 1 into the equation of the circle given. That means we are going to have 1 squared plus y squared plus 18x. So 18 times 1 plus 20y plus 81 is equal to 0. So we will simplify and that will give us y squared plus 20y plus, so we have 1 plus 18, that will be 19, plus 81, that will be 100, is equal to 0. Now looking at 20 and 100, I can rewrite as y squared plus 10y plus another 10y plus 100 is equal to 0. So I have y 1 plus 10, then 10 out, y plus 10 equals 0. So my my numbers now become y plus 10 multiplying another y plus 10 is equal to 0. So it's giving us a repeated root. So y plus 10 is equal to 0, and that means y is equal to -10. And this value is a repeated value, so we will have it at one particular point. Now we already have the value of s to be equal to 1, and then we have y to be equal to -10. That means the point of intersection is the point 1, -10. That's it. Are the points 3, -4 and 4, 1 inside or outside the circle x squared plus y squared minus 4x plus 6y minus 3 equals 0? Okay, so solution. Now we are going to use two different approaches to solve this question. So the first thing we are going to do is to determine the length of the radius of the circle. So looking at our circle, our 2j is equal to -4. So our j is -2 and our a will be +2. 2f is equal to 6. Our f is equal to 3 and our b will be equal to -3. That means the center of the circle is 2, -3. With that, we can determine our radius r is equal to j squared plus f squared. So we have -2 squared plus 3 squared minus c. So our C is already negative, so minus negative 3. We have 2 squared, which is 4, plus 3 squared, 9, and then plus 3. This gives us root of 16. And so our radius is 4 units. Now we are going to take each point together with the center to determine the length from the point to the center and compare. So we are taking the point P, which is 3 minus 1, and the center 2 minus 3. We are going to compare the length. So we will have 3 minus 2 squared plus minus 1 plus 3 squared. Okay, so when we compare, we are getting 1 squared, which is 1, plus 2 squared, which is 4. And that will give us root of 5. And root 5 is less than 4. So root 5 units is less than root 4 units. That means that the distance between the point P and the center is less than the radius of the circle. Therefore, the point P, which is 3, negative 1, is inside the circle. Then we also take the point Q, the point 4, 1, and compare with and look at the distance between the point and the center. So we compare the length, and that will be 4 minus 2 squared plus 1 minus negative 3, which is 4, which is plus 3, also squared. And that will give me 2 squared is 4 plus 4 squared is 16, which will be square root of 20. The square root of 20 means we will have 2 root 5. And this is equal to 4.47, which can be seen as 4.5. And that means 2 root 5 is greater than 4. Therefore, the point Q, which is 4, 1, lies outside the circle. Okay. The second approach we are using to solve the same question, we are going to remember that once a point is on a circle, it satisfies the equation. So we have our circle, x squared plus y squared minus 4x plus 6y minus 3 equal to 0. So if we substitute the point P and the result we get is 0, then it means the point P lies on the circle. If the result is less than 0, then it means the point P lies within the circle. And if it is more than 0, it means it is outside the circle. So what we are going to do is to substitute the point P into the equation. So we have x squared plus y squared minus 4x plus 6y
minus 3 equal to 0. We are substituting the point P. So 3 squared plus minus y squared minus 1 squared minus 4 times 3 plus 6 times minus 1 minus 3 is equal to 0. We are going to check. So this is 9 minus 1, plus 1 minus 12 minus 6 minus 3 is equal to 0. 9 plus 1 is 10, minus 12 is negative 2, minus 6 is negative 8, minus 3 is in negative 11. So negative 11 is not equal to 0. It is less than 0. So it means the point P, which is 3, negative 1, lies inside the circle. Then we also check for point Q. So 4 squared plus 1 squared plus minus 4 times 4 plus 6 times 1 minus 3 equals 0. 4 is 16 plus 1 minus 16 plus 6 minus 3 equals 0. So 16 plus 1, 17 minus 16, negative, it will be 1 plus 6, that's 7 minus 3, that will be 4. And 4 is not equal to 0. 4 is greater than 0. And once 4 is greater than 0, it means the point Q, which is 4, 1, lies outside the circle. So these are the two ways of checking whether a point lies inside or outside a circle. Intersection of circles. When two circles intersect, there are three situations that can arise. The situation where the two circles intersect or meet at two different points. The situation where the two circles meet at one point, and the situation where the two circles do not even meet at all. So we take the look at our first situation. This is our first circle, our second circle. We are labeling the center of the first circle as A, and then we will see how they meet. We also label the center of the second circle as B. Now, when the two circles intersect at two different points, look at their radii. What has happened? You see that the two radii, when you look at the distance between their centers, it should be shorter than when you sum their radii. Okay, so for two circles to intersect at 2 points, the distance between their radii will be shorter than the sum of their radii. So let's take note of this point. Now the second situation, if we label here as A and we label here as B, their centers, and then we also choose to label their radii R1 and R2, we see that the two circles are intersecting at one point. But here, there is another thing we should note. They are intersecting at one point, but the intersection is external. So when we have an external intersection at one point, we will have the distance between their centers being equal to the sum of their radii. So this is the situation. We can also have a situation where the so in the second situation, or for the internal one, what happens is that the circles meet at one point, but this time the meeting is internal. And if the meeting is internal, this is what happens. You see, if I label the center of the bigger one as A and the center of the smaller one as B, then you see that the distance between their centers AB will be equal to the difference between their radii. So you see, it is the same intersection at one point, but this one is in internal and the condition is different. And the previous one, which was external, the condition was also different. I hope this is understandable. The third situation, so we are labeling here as A, we label here as B. The two circles do not even intersect at all. So look at the distance between their centers, and then we compare with the sum of their radii. So we label here R1, we label here R2. Now, the distance between their centers will be greater than the sum of their radii. In this case, or in this situation, it means the two circles do not intersect at all. Show that the circles, this one and this one, touch externally. Our solution. So we are going to take our first circle, that is x squared plus y squared minus 16x minus 12y plus 75 is equal to 0. Now, 2g is equal to minus 16, g is equal to minus 8, and a is equal to 8. 2f is equal to minus 12, f is equal to minus 6, and b is equal to 6. So taking this circle, our center is 8, 6. Now what will be the radius of the circle? So we label that as our R1, and that is going to be equal to j squared minus 8 squared plus f squared, which is minus 6 squared, minus c, that is negative 75. That will give us 8 squared is 64, and then 6 squared is 36 minus 75. So 100 minus 75 is 25, and that our r squared is 5 units. So that's the radius of the first circle. Then we take the second circle. So here we have c to be 75. Now for our second circle, we have 5 s squared plus 5y squared minus 32x minus 24y
plus 75 is equal to 0. So before we can do the comparison, we have to divide through by 5. That will give us x squared plus y squared minus 32 over 5x minus 24 over 5y plus 75 over 5. That will be 15 is equal to 0. Now from here we have our 2j to be equal to minus 32 over 5. That means our j is going to be minus 32 over 10. And that a is going to be 32 over 10. Then our 2f is going to be minus 24 over 5. So our f is going to be minus 24 over 10. And that's my b is going to be positive 24 over 10. Okay, so the center of this circle will be 32 over 10 and then 24 over 10. And then the c is 15. Okay, so what will be the radius of this circle? R2. That will be square root of j squared, which is minus 32 over 10 squared. And then I'll add it to f squared, which is minus 24 over 10, also squared, minus 15. That is the c. So R2 will give me 1024 over 100 plus 576 over 100 minus 15. So my R2 will be equal to root of 1, which is equal to 1. And that will be the radius of the second circle. Now I have the radius of the two circles. And according to the question, we are proving that the two circles touch externally. Now when we checked, we realized that if the two circles touch externally, then the distance between their centers AB. So let me label their centers as A and B. So this one as A and then this one as B. So distance between their centers AB should be equal to the sum of their radii. Okay. Now we have our center of the first circle, which we labeled as A, as 8, 6, and its radius R1 as 5 units. Then we have the center of the second circle, which was 32 over 10 and 24 over 10, which we can rewrite as 3.2 and 2.4. And the radius R2 was equal to 1 unit. Okay, so now we are going to find the distance between the centers AB, and that will be 8 minus 3.2 squared plus 6 minus 2.4 squared, and that will be equal to 4.8 squared plus 3.6 squared, and that is going to give me 23.04 plus 12.96, and when I add the two, I'll get 36, and square root of 36 is 6 units. Okay, now I want to see whether the distance AB will be equal to the sum of the radii R1 and R2. So we have 6 units is it equal to 5 plus 1 unit. And yes, 6 units is equal to another 6 units. And that shows that indeed the two circles touch externally. Okay, so if you remember um, the the circle where we had it touching and the radii was like that. Okay, find the point of intersection of the circles given by this and this. Okay, so we're going to have as our solution. We're going to have s squared plus y squared minus x plus y equal to 4 as our equation 1, and then s squared plus y squared equal to 5 as our equation 2. Okay, now I'm going to multiply equation 2 by -1. So if I do that, I'll get, and then the result, I'll add it to equation 1. Okay, so firstly, my equation 2 becomes negative s squared minus y squared is equal to -5. And when I add it to equation 1, the s squared component will go away, the y squared component will go away, and I will be left with negative x plus y is equal to -1. So that is what I will get. Now, if I decide to make y the subject from here, I'll get y to be equal to x minus 1. Now, I'm going to substitute x minus 1 into equation 2. And when I do, I'll get s squared plus x minus 1 squared is equal to 5. So s squared here plus s squared minus 2x plus 1 is equal to 5. So I have 2s squared minus 2x, and then minus 4 is equal to 0. If I divide through by 2, I will get s squared minus x minus 2 is equal to 0. Okay,
So now I find my roots. That I'll have s squared my plus x minus 2x minus 2 is equal to 0. And that's s x plus 1 minus 2x plus 1 equals 0. So I have s minus 2 and I have x plus 1 equals 0. So x is equal to 2 and x is equal to minus 1. Okay, so taking that, I'll have if x is if x is 2, then y will be equal to, so from the expression here, from the expression y is equal to x minus 1. If s is equal to 2, then y will be 2 minus 1 and y will be equal to 1, giving me the point 2, 1. And then if s is equal to negative 1, then y will be equal to negative 1 minus 1, which will give me y is equal to negative 2. And that will also give me the point negative 1, negative 2. And that is it. Now we look at orthogonal circles. Now when two circles meet such that the tangents of each of the circles at the point of contact, that is the point where the two circles meet, if the tangents at those points meet perpendicularly, then the two circles are said to be orthogonal circles. So as we can see from the diagram, we see, let's label the tangent for this circle as L1 and the tangent for this circle as L2. Now we see that L1 and L2 intersect at the point here, and the angle between the two lines is 90 degrees. So when this happens, we say the two circles are orthogonal circles. Now, once the angle here is 90 degrees, it means the angle here is also 90 degrees. And when I decide to draw a straight line to join their centers, then I get a right angle triangle formed with their the distance between their centers being the hypotenuse, that is the longest side. Okay, so with that, we can say that, and each one is a radius. So if I label this as R1 and I label this as R2, then there is a condition that it satisfies here. So the D as I used here is the distance AB. And so the distance AB squared, the distance AB squared is equal to R1 squared plus R2 squared. That is the Pythagoras theorem developed from the triangle that we have drawn here. I hope this is understandable. And so when we have two circles and we are to show or to prove whether they are orthogonal, that is the first condition we can use. And then also, orthogonal circles also satisfies this condition. That is 2 times J1, J2 plus 2 times F1, F2. Remember, J1, J2 represents their centers. and then F1, F2 also. And when we sum the two, it should give us C1 plus C2. Okay. Show that the circles x squared plus y squared minus 8x minus 6y plus 21 equals 0, and the circle x squared plus y squared minus 2y minus 15 is equal to 0 are orthogonal. Okay, solution. Now, I'll take my first circle, and from my first circle, 2j is equal to minus 8. So j is equal to minus 4. And then 2f is equal to minus 6. So f is equal to minus 3. And then the c is equal to 21. Then I take the second circle. 2j is equal to 0. J is equal to 0. And then 2f is equal to minus 2. F is equal to minus 1. And then c is equal to minus 15. So using the condition 2 times J1, J2 plus 2 times F1, F2 equal to C1 plus C2. I'm going to show that the two circles are orthogonal. Okay, so 2 times my J1 is negative 4, but my J2 is 0. I'm adding it to 2 times my F1 is negative 3, and my F2 is negative 1. And that should be equal to 21 minus, okay, here is minus 15. 21 minus 15. Okay, so this side goes to 0 plus 3 times 1. Negative 3, negative 1 becomes positive 3 times 2. That will give me 6. 21 minus 15 will also give me 6. Okay, so 6 is equal to 6. That shows that the two circles are orthogonal. Show that the circles x squared plus y squared minus 8x plus 6y minus 23 equals 0, and the circle x squared plus y squared minus 2x minus 5y plus 16 equals 0 are orthogonal. Okay, so for orthogonal circles, we have 2j1, j2 plus 2f1, f2 to be equal to c1 plus c2. So when we take the first circle, our 2j1 will be equal to negative 8. So our j1 is equal to minus 4. Then our 2f1 will be equal to 6. Our f1 will be equal to 3. And our c is equal to minus 23. Then when we take the second circle, our 2j2 will be equal to negative 2. So our j2 will be equal to negative 1. Then 2f2 is equal to negative 5. Our f2 is equal to negative 5 over 2. And our c is 16. So we see how we prove it. So 2 times j1, which is negative 4, times j2, which is negative 1. We are adding it to 2 times f1, which is 3, multiplying f2, which is negative 5 over 2. And then this should be equal to negative 23 plus 16. So negative 4 times negative 1 will be positive 4 times 2, 8. And then 2 here can cancel the denominator here. 3 times negative 5 will be negative 15. And minus 23 plus 16. So here we have negative 7. Here we have negative 7. And since they are equal, it proves that the two circles are orthogonal as required.